All right, so I'd already talked about what the average value looked like, so let's just draw another picture here. So if I have A to B, and I've got some curve that looks like this perhaps, so the average y value that's hit, so let me give you an idea of something that it could look like. The average y value would be this y value here, right? So this y value, and that's what this f of c would be, this average y value, the average height that is reached. So this is actually a point on the graph. So this is, we're going to call it f of c, and this c is an x value that's between a and b. It could be a or it could be b. So this is some c value that's between a and b. And let me give you an interesting application here. So what this is, if I take this equation and just rewrite it and multiply by b minus a, right? So this b minus a just coming over, so these are equivalent. So this is talking about b minus a being this width, and then f of c being this height, right, f of c, there is a rectangle here. The area of this rectangle is the same as the area under the curve. That's pretty profound, that I can find one y value that has an x value that corresponds to it. So I have this red rectangle is the same as the exact area under the curve. So that's when we're asked to find the value of c that satisfies the mean value theorem for integrals, like in this example 3 here, that's what I'm being asked to find. All right, so I'm going to set it up with this equation. So I have f of c times b minus a equals the integral from a to b of f of x dx. All right, so f of c is this function with c plugged in, 1 plus c squared. B minus a would be 2, subtract a negative 1, so that'll give me a 3, equaling from negative 1 to 2, and then inside here I've got this function that I need to integrate. All right, so I still have 3 times 1 plus c squared, and taking the antiderivative, so I get x plus 1/3 x cubed between negative 1 and 2. So 3 times 1 plus c squared, I'm going to keep it over here. So plug in the 2, so I get 2 plus 8/3, subtract off, putting in the negative 1, so I get negative 1 minus 1/3. So 3 times 1 plus c squared, so I'm off to find c, correct? So I get 6/3 plus 8/3, so that's 14/3. And then subtracting off, and this gives me a negative 4/3, so I'm going to be adding a 4/3. So 1 plus c squared is equal to 18/3, which is equal to 6. I'm going to divide through by this 3 as well, and do two things at once, so I should get 2 over here. So c squared is 1, so c is equal to plus or minus 1. All right, so this value of c has to be between, or it could be included in the endpoints here, so both of these values work, so that's good. All right, let's do another one here. So this is value of c that satisfies the mean value theorem, so b minus a will give me 4 times root c integral 0 to 4 root x dx. So keep this over here, take the antiderivative, so 2/3 x to the 3/2, 0 to 4. So I'll get 2/3, 4 to the 3/2. So let's think about that a second. That's the same thing as saying the square root of 4, which is 2, cubed, that's 8. So 8 times 2 is 16/3. So root c divided through by 4, so that gives me 4/3. So be careful here. I'm going to square this, so I get 16/9. So that value is in between 0 and 4, and that's it. All right, so I've given you more integrals here. This I want you to memorize. I want you to know the integral of tangent is ln of secant, or you could write it as negative ln of cosine, so you don't have to go through this. Another one you want you to memorize, integral of cotangent, is ln of sine. And these here are just worked out examples that I've given you that are a little more challenging, but I think you can figure them out from all the work, so I'm not going to invest time in re-lecturing on them. I'll leave that for you to study and ask questions.